Hey everyone, welcome. My name is Ivan, and today we will talk about the Arx structure. So I'm really excited because next previous video or previous streaming, I talked a bit about like a brief introduction about the ArxLang, the Arx compiler. And today my plan is to talk more about the structure. Okay, so yeah, I think we can just start. Give me 1 second. All right, so all the development we are doing for Arx, we are doing on GitHub. Okay, basically we have two main repositories. One is Arx. This repository is for all the code, and we have Arx proposals. So any change in the language will be done previously through a proposal. Here we have a name we called Arx Enhancement Proposal, and let me show you some proposal here. For example, I think documentation, maybe TLC. Yep, no, it's not this one. Give me 1 second. This one. Comments in docstring. So we had a pull request here proposing what would be the documentation structure and the docstring, actually the comments and docstrings structure. All right, it was a very long time ago. Probably we should revisit this, but at least we created some initial mechanism for new proposals. All right, but this is about the language syntax or some kind of structure as well. But for the compiler per se, for example, that would be great to have an implementation to output the LLVM IR from the source code, for example. It doesn't need to pass through a proposal enhancement. Okay, and in the next streaming, we will talk a bit more about this specific case, the LLVM IR. Okay, so basically we have everything on GitHub. We use GitHub Actions for the CI, the continuous integration. We have also a job for Conda build. Everything we are doing on Arx, we are doing using Conda environment. So this is a really important step for the project, because also maybe in the future the package management will be done using Conda build, and maybe we have already Anaconda channel for ArxLang, or maybe we can use the Conda fork. Probably, I think it would be better to use a specific channel in order to avoid any problem in the future. But yeah, it's also possible to use Conda fork as well. Okay, and we have here a workflow for release, and we are using for the release, we are using the semantic release. Okay, that helps us a lot in the process. It's really simple in general, and it can help in different steps of the release process. Okay, I will not give too much details about that, at least not now, because we have a lot of things to discuss. As I mentioned, everything is based on, at least related to the environment, everything is done using Conda. For now, we are just supporting Linux, but we hope to support macOS as well in the near future. Okay. We have here also a support for container. So maybe if you don't have Linux, you can try it using containers. Specifically, it is using Docker. We didn't try with Podman, but at least with Docker, it was working. Actually, it would be great to have GitHub action to test the Docker infrastructure as well. The documentation, we are using Doxygen, and also we are using AMK docs. Okay, so if we go to arxlang.org, so we have this page. It is done using AMK docs, and we have tutorials. Not sure if it's really working because we have some changes. Also, we need to improve more the tutorials part. API doc, not sure if the name is a good one, but basically it is the internal part of the compiler. Okay, where we have releases notes, namespace, classes, files, and so on. So it's using Doxygen, okay, with an extension. Let me check the name of the extension. Let me check plugin, and the name is Doxygen Awesome CSS. Okay. All right. We have also a folder for examples. In this case, it's just Arx examples, really simple. All right, so the ArxLang is based initially on LLVM Kaleidoscope tutorial. And so the language is very similar. I just made some few changes. The compiler, the structure is different. Because LLVM Kaleidoscope basically is just one file, and now I have one file for each phase. It is using visitor design pattern, and we can generate objects. We can generate output from the AST, and the next step would be to have output for LLVM IR as well. Okay, so in this case, I will say that it's very different in general. Of course, I'm using the basic structure for parsing and code generation that is used by LLVM IR, but it's much more complex, much more complete. It has tests using Google tests. The phases are split into different files. It's using the visitor design pattern, where the parsing generate AST object, and the compiler that compiles these AST to object files receive these AST object, and so everything is like composed, isolated, kind of. Okay. So here we have some scripts that helps with some tasks. For example, the format release, that's changing a bit something in the documentation stuff, something like a workaround, something for include what you use that actually now it's not really working. Well, we need to improve that. opt clean basically is just a script that helps to remove all temporary files when we are building the project. And ArxLang tidy is a workaround as well. We move it from CMake to Mason, and the clang tidy is not working anymore, so we needed to keep the compile comments.json provided by the CMake, and we needed to do some adjustments, and we are using that for the clang tidy call. Okay, I hope to have it resolved soon, but actually I'm not super sure. I have tried a few times, but with no success. Okay. All right. So I think the next steps will be talking. We'll be talking about SRC and tests. Okay. Also, I would like to talk about the pre-commit hook. I think that's an important step in the development workflow. Let's start with this one. So basically, we are using now as a mechanism to prevent pushing code with wrong format or not in good shape and so on. So we are using the pre-commit hook. So it's a library called the pre-commit, and it adds to the GitHub repository the local GitHub repository, a hook when you run the git commit command. Okay, when you run the git commit command before doing the finalize the commit command, it will first run some sets of validation. Okay, so in this case, I'm using clang tidy, clang format, and the CPP check. That would be great if we have more, and also here the end of file fixer and the trailing white space fixer. Okay, so it would be great to add more tools here, like maybe the shell check, for example. I think that would be very nice to have some code quality check for the shell scripts, for example. And of course, we can add more checks here to improve our code quality. Okay. Sorry. Let's go. Of course, we have here a sponsor button, and if you want to sponsor a project, that would be very great. And okay, let's go to the source folder. All right, so here we have all the files for the project. We have error, TPP, and also the age file, the header. We have files for I/O. This JIT is from LLVM Kaleidoscope tutorial. We have files for Lexer, for parser, and utils. Maybe probably would be good to have a better name for these utils because it doesn't explain very well what it is doing, right? So, and also we have the code generation. Okay, so we have code generation for files objects. We have a generation for std out. In this case, it's AST to std out. And next we will have AST to LLVM-IR. Okay. All right. So if we go to main, we are using here CLI 11 for parsing the compiler arguments. Okay, we have some options here. We can open the shell. Currently not sure if it's really working after all the changes we did in the past. We can just check the version. We can show the AST, and we can actually compile to an object file. In a future, we need, in a near future, we needed to implement also the compilation to executable. Okay, for now we just have the compilation to object files. So we needed to have a main a CPP main file with a main function that will include our initial or desired function from Arx. Okay, but I hope to have it ready maybe this month. Probably shouldn't be that hard. Okay, and so yeah, we can jump to the code generation, or yeah, actually it would be good to take a look into the steps first. So we have first the lexer. So I'm trying to use classes for the lexer. Oh, actually for each phase. I think it's easier to organize all the functions, attributes, and so on in just one class. It will keep everything more clear and transparent. Okay, for now we have tokens like for end of file, function, return. Return actually is not used yet, but because the language is not using return keyword, but that will be next step for the project as well in terms of syntax. Extern identifier number. Currently we just support doubles as data type. The next step also would be to support more data types, but the key core of the project is support Apache Arrow data types. So probably the other steps would be after we have at least the first Apache Arrow data type inside the compiler. Okay. We have support for if, then, else, for, in, binary, unary operations, variables, and const. Actually, const is not used yet, but yeah, it should be implemented this year. Okay. All right. So yeah, we have a lot of things here. I think we don't need to go into details right now. We have parser. So the parser has the expressions classes, and everything is processed using visitors. So we have expression AST that can be of any kind. Okay, and this is a kind of a downcasting, and according to this downcasting, it will call the correct visitor visit method. Okay. So yeah, it's the same thing. We have just one class with all the parameters, attributes, function methods, and so on. So it's a way to have everything organized in just one point. I'm calling everything statically. I'm not instantiating lexer or parser class. It helps us to have things more flexible, at least for now. Not sure in the future, but at least for now, it's helping a lot with this flexibility. And this is the main function or main method that will walk the lexer, the result from the lexer, and create our AST. Okay. So after that, the next step will be the code generation. We can talk about maybe this AST2 standard output. I think this is the last implementation, and maybe it will be easy to explain. So we have a visit method for each expression class, and basically we are just printing output about the structure of the object. Okay, the expression object. So that's not super complex. So maybe if you want to take a look in initial implementation, I think that would be the easiest one for the code generation. Also, we have here a print AST function. I'm not sure if it's the best name, but it's a simple one. And basically it's instantiating the AST to output visitor and walking the nodes and calling the visitor for each kind of node, basically. Okay. And the main code generation, in this case to file object, is AST to object, and it is using LLVM for the code generation. Okay. So of course I will not take too much time to explain this code, because it will take a long time for that. But basically it's the same. We have a visit method for each expression object. All right, it is using LLVM, and we have like a main function at the end that's creating all the structure, and also we have a main loop method here. I hope main loop, okay, that will walk the nodes from the AST tree. Actually, AST tree is redundant, just AST. Okay. All right. So I think in general that's the structure of the code of the project. It's really simple. As I mentioned, it's based on LLVM Kaleidoscope. So if you want to take a look more about the LLVM Kaleidoscope, you can go to the llvm.org page. So if you want more explanation about the code, also you can take a look into that. Of course, it's really simple compared to Arx because it doesn't have tests or any infrastructure code. It doesn't work with visitor design pattern and so on. But about the LLVM code generation, it will be basically the same. All right, until at least until the item 8, the chapter 8. Now the LLVM IR generation on Arx will be based on the Kaleidoscope chapter 9. Okay, so in the next streaming, the plan is to implement this item that basically is the same code we have for the file object, but implementing this debug information. All right, so yeah, I think that's all for today. Thanks for watching, and I hope to see you next video later.